This is a video for 11 Plus on products of primes. It's a pretty simple concept, but it's pretty important for the 11 Plus exam because it can distinguish between people who are doing okay and people who are doing very well. The basic idea will come from a question like this. Express a number, say 270, as the product of its primes, or express 270 using prime factors, or using your knowledge of primes, rewrite 270, or that kind of question. It also comes up in lowest common multiples, or when you're looking at when two times tables combine. For example, when does the 6 times table meet the 7 times table? Or if two runners leave on a track running at different speeds and they lap at different times, when do they reach the start line again at the same time? And we'll go into that in a separate module called lowest common multiple, but first you just need to know how to create products of primes. So the first thing is that a product is that, a times multiple. And the second thing you need to know is your primes are 2, 3, 5, 7, 11, 13, 17, 19, and so on. But those are your primes up to 20. So you want to know those, and we'll do maybe a separate video on those. So, express 270 as the product of its primes. Now, what I do is a form of short division, but I do it sort of upside down. So the first thing I do, I'm going to write my primes on a list at the top. So 2, 3, 5, 7, 11, and I'll stop at 13 because it's only 11 plus. Now 270, instead of the bus stop on the top, I put the bus stop on the bottom, and I check for my first prime, which is 2. So I'm not going to move on from 2 until I've exhausted 2. So the 2's go into 270, yes they do, so 2, and that becomes 135. Okay, and that's just standard short division. The 2's go into 135, no they don't, because it's an odd number, so you know they don't go in, so you can cross out the 2. The 3's go into 135. Now there's a magic rule to find out if 3's go into any number, and that's you add the digits, you add the individual digits up, and you see if that number, the sum of the digits, is divisible by 3. So if we add 1 plus 3, that's 4, plus 5 is 9. 9 is in the 3 times table, so yes, it is divisible by 3. Even though it ends with a 5, we want to divide by 3 first. 3's into 13, go 4 times remainder 1, and 3's into 15, go 5. So that's 45 times 3 is 135, or 135 divided by 3 is 45. Is that divisible by 3? Well, let's add the 4 and the 4 and the 5 to make 9. 9 is in the 3 times table, so yes, we can divide this by 3 again. 3's into 4, go 1, carry the 1. 3's into 15, go 5. Well, we actually should know that 15 is divisible by 3, but let's say we don't. We add 1 and 5 to get 6. 6 is in the 3 times table, so yeah, it is divisible again. And if you look, we've now got 2, 3, 3, 3, and these are all the primes, the prime factors. So let's finish dividing 15 by 3 to get 5. Now, 5 is not divisible by 3, so we can cancel out 3. Can we divide 5 by 5? Yes, of course we can. And we get 1. When we get 1 on the bottom, we're done. Now, we have to list the number as the product of its primes. To do that, we put 270 equals, and then 2 times, make sure it's times, it's not plus, times. And then we count the number of 3's. 1, 2, 3 3's. So it's 3 to the power of 3. That means 3 times 3 times 3. Okay? 3 to the power of 3, and then go back to here, times 5. So 270 as the product of its primes is 2 times 3 to the 3 times 5, and that's otherwise known as 3 cubed. But just remember the number. The number has to reflect how many 3's here. Now maybe let's have another little go and practice somewhat. So let's pick another number. Let's say 360. So 360 I'm going to do this one a little slower so you can work along with it. 360, write it there, and you put it in a backwards bus stop. Now I list my primes: 2, 3, 5, 7, 11, 13, and that'll do. My first prime is 2, so let's be systematic. And you should be already doing this. You put a 2 here, and you divide. 2's into 3, go once, remainder 1. 2's into 16, go 8, remainder 0. And 2's into 0 goes 0. And this is just standard division. Now, even though I can divide 180 by 3, I want to stay with my 2's. So let's stay with our 2's. 2's into 1 don't go. 2's into 18 go 9 times, and then the 0. And there. And once again, you can recognize this as a multiple of 3, but we're going to stay with the 2's. 2's into 90 make 45. Can't do 2 into that. I've run out of 2, so I cancel my 2. 3's into 45. Yes, I can, because I add the 4 and a 5 to get 9. It's in the 3 times table, so I put 3's into 45, 15. Once again, don't jump to the 5 here. Stay with the 3's. 5 plus 1 is 6, so it's in the 3 times table, so I can do it by 3. And here's my 5. Now, 5, I have to cross out the 3 and go for the 5. So I put a 5 here, and I get a 1 at the bottom. Let's list it out. 360 equals 2, and then 1, 2, 3. 2 to the power of 3 times 3, because I can see I've got a 3 here. 1, 2, squared, times 5. Pretty easy. Right, I suggest what you do is you just have a go with a few numbers. Maybe we'll do one more, and then we'll move on. Right, I'm just picking a number at random here, and I hope it hasn't got any massive weird primes. 486. Let's have a go at this product of primes. I put my primes up here. And just those to start with, that's good enough. You might need to go into further primes, like 17, 19, but stick with those to start with. Right, start with my 2. 2's into 4 go 2, 2's into 8 go 4, 2's into 6 go 3, 2, 4, 3. So that's half of 486. Can I divide that by 2? No, because it's an odd number, so got rid of my 2's. Can I divide 243 by 3? Yes, I can. Let's just check. It's 2 plus 4 is 6 plus 3 is 9. That is in the 3 times tables. So we got a 3 there. 3's into 2 don't go, so carry the 2. 3's into 24 go 8 times, and 3's into 3 go once. So it's 81. We know that 81 is a multiple of 3, but let's just check. 8 plus 1 is 9. Yes, it's in the 3 times table. So put a 3 there, and it becomes 3's into 8 go twice, remainder 2, and 3's into 21 go 7, and these familiar 3 times powers of 3 numbers will come up. Does 3 go into 27? Yes, because 2 plus 7 is 9, it's in the 3 times table, so we put a 3 there. 3's into 27, doesn't go into the 2, carry the 2, and it's 3 times 9. Of course we can do 3's into 9, go 3, and 3's into 3 go 1. So that's all we needed. We needed 1, 2, and lots of 3's. So let's just be clear about this. 486, as a product of its primes, or its prime factors, not its factors, which are a different thing, but its prime factors are 2 times 3, and then 3 to the power of 1, 2, 3, 4, 5. 3 to the power of 5. And that's it. 486 equals 2 times 3 to the power of 5. I think that's enough for now. Go and pick some numbers, random numbers, and practice on them. You might get some heavy primes, like 17 and 19 and so on, but that's okay. Just treat that as practice.